Okay, so I'm going to start with the basics. This is actually module 3 here, but the first couple of modules was actually just setting up Visual Studio Code and downloading and installing Python, which I might make some videos for as well. Um, but what we're going to do here is just start really from the front basics of Python and kind of like what is what and so forth. And the first thing is you can see over here, and I actually might even, if I get rid of this thing here, just so I can make my screen big when do Control plus a few times. Just makes the font a little bit bigger so everyone can see things. There's some colouring. I'm using dark mode at the moment, but I could be using any kind of colouring mode. So that's more a case of the editor that I'm using. So themes here, colour theme. I could have. I've got the dark video over here, but I could have kind of like, I don't know. Let's pick a light one. Default light mode would have looked like this. It's just a little bit blinding, so it's quite nice to work in dark mode. So, and you could use Google Colabs, and you could also use the Jupyter Labs or the Jupyter Notebook. So it's kind of like that. The choice of your editor is just a thing, and I do go over that in other sessions. But in this particular session, we're just going to focus on the Python coding. So let's just go back to Dark Visual Studio, the default dark mode, I think it was. But anyway, you know, what is Python and or not what is Python, but kind of like the coding of it. And the first thing that we've just got to know is that everything in green here is a comment. So basically, if I want to put a comment in, and these things aren't read by the interpreter, so this is a comment. And I've actually called it a single line comment, and the reason for that, we'll see it in a later block, but you can also do a multi-line comment, which has got 3 quotations and ends in 3 quotations. So this is basically here, this is a multi-line comment. It spans many lines. We will get into things like indentation. But basically the multi-line comment allows for that, and that's perfectly fine in Python. Python very much works on indentation, and we'll look at that later on. Anyway, for the purpose of what we're doing, a single line comment is more than sufficient. And one of the things I might talk about is type inference. So first of all, we'll move on to strings and kind of like what is a string in Python. So you know, we can set on the left hand side again, our variables are in blue, and our values here, we see some values that are in an orangey sort of red colour, and then here we see other types of values that are in a blue colour, and other types of values that are in green. So they all get their different colour coding. In terms of what is a string in Python, it can be written so a string can be written like this. Is anything that's in single quotes, or it could be in double quotes. So hi there, that's a string, but we could also write it. We could also write the same thing like this, the underscore string equals, and we could put it in double quotes. So hi there. So both single quotes and double quotes are allowed. You might say, why is it single quotes and double quotes allowed? There's a couple of different reasons for that. We won't get into it at this point in time, but one thing is for sure, if we wanted to put quotes inside of quotes, we couldn't put single quotes inside single quotes, because this single quote here effectively ends this one, and then this looks like an open variable, so it looks like an error in Python. But it would work if we put double quotes inside single quotes, so we could have something like this. But we'll continue from that anyway. We can define a variable. We'll call our variable A, and we'll assign it the string hello world. And unlike other languages, we could put just the whole string as is in Python. We don't have to make any declarations. So this is called type inference. In other languages, you might have to declare a string or a string like this, str, depends on which language that you're in, or alternatively, if you're in C++, you'd have to do a standard double colon string. This would be the C++ version, so which is quite lengthy. Python is very flexible like that. Now, we can assign a string and just give it one character, so assign it to the variable a, but it's not very descriptive. So it is concise, and we can use it for the purpose of this course because we're only talking about a small block of code that we'll go over here. So A is concise but not very descriptive, but we could use something a bit more descriptive, which is my underscore string, and we could set it to equal hello world, and this is a bit more descriptive. This particular casing using this underscore is called snake case, and that is the case that's used in Python. It's the most common case. But then we could also use this case here, which is camel case, which is, in fact, I think it's called Pascal case when you've got the first letter capitalized. So my string like this would actually be camel case. When you do, this case tends to be used in other languages. We tend to use the underscore in Python, but it's your choice. You can do what you like, and you can also do a mix of casing. So this has got an underscore and it's also got a capital, so that's called mixed case. These two are the most common, which is line 7 and line 8, and the Pythonic way or the accepted way in Python is to use the underscore, which is a snake case. The next variable after moving on from strings, so that's kind of like our really basic string types, and when we run our code, I've just hit control return. The codes run at the block down at the bottom, and I think somewhere we do a print A just further down on line number 25. Remembering that our Python interpreter runs line by line, so it first lines from line number 1, but line number 1 just happens to be a comment, line number 2 is blank, line number 3 is another single line comment, line number 4 is blank, line number 5 is another single line comment, and then finally on line number 6 is our first line of code where Python gets its first, the interpreter gets its first instruction, and it assigns A the value of hello world. On line number 7 it assigns my underscore string the value of hello world. On line number 8 again we've got another version of my string, but this time with the capitalized S for the camel case as hello world, and finally the mixed case. So we've got a few things that are going into the interpreter, 1, 2, 3, 4 things that have gone into the interpreter at this point in time. The code keeps running down, and our first print statement, which is how we output something to the console or to the output in Python. And if I hover over it, it prints values to a stream, which is quite convenient in other languages. Again, like in Node.js, we do log console.log, which means log to the console, and in C++ we would do standard : C out, which is the console output. And the Pythonic version of it is this print statement. That's quite useful. And we print A here, and when we do print A has been assigned the value of hello world. So just down below we get a hello world for the print A statement. And likewise, our next variable is a Boolean. So again, line 10 is blank, line 11 is a single line comment, and then we set B equals, and then whatever we wanted to set it to, and we've decided to set it to true. Notice that Booleans start with a capital, so it's capital T for true, and you can see also that it's got a dark blue colouring as opposed to a string, which is an orange colouring here in the dark mode, and it's encapsulated in the single quotes. And what is a Boolean in Python? It effectively is a 1 or a 0 or a 1 or an on or an off, or a true or a false. I should actually put a 1 or 0 just to be consistent with the other ones. So it's either true or false, which is 1 or 0, or on or off, and again true or false over here. They're the two options. So for example, we could say the lights are on equals false. Now this is more descriptive as a variable, again just assigning or just naming our variable as B is not descriptive. It wouldn't be great in a large block of code. It's okay in a small block of code. So that's strings done, and then that's Booleans. And when we do print B, again we do print B here on line number 26, and B was assigned its value in line number 12, and it was assigned the value of true. So when we do print B, we get this true over here. And then also moving on, we can create floating point numbers. What is a floating point number? Well, we can move on to integers next, actually, before we get on to floating point numbers. Again, here's our little comment on line number 15, and line number 16 we assign another variable. We just call it C, and we've assigned it the value of 10. We could have picked any integer number that we wanted, so 10, 11, 100, they're all integers. So we assign it the value of 10, and then we move on further down to line number 18, and we assign a floating point number, and so we create another variable. We call this one D because we've used A, B, and C already. We've used A up here for hello world, we've used B for Boolean, and we've used C for integers, so we use D for floating point numbers. And you've noticed here maybe that I've put in a 10.0. Now, you might say that 10.0 is 10, which is therefore an integer, but the minute that Python sees the point, the decimal over here, it recognizes, or it does something called type inference. And again, in other languages, we would have had to have said int or integer to define our variable before, but Python does something called type inference. It automatically knows that this is an integer, it automatically knows that this is a Boolean, it automatically knows that this is a string, and likewise, if there's a decimal place, it automatically notices or infers that this variable, the variable D, is of type float as opposed to being an integer. And it's probably more recognizable if we put like D1, create another variable of D, but this time we'll call it D1, and we'll say 9.995, and this is definitely not an integer, and it's definitely a floating point number. So again, Python type infers it to a float. But they're the four native data types, which are string, Boolean, integer, and float. They're the four native data types, but there are other types that exist in Python as well, and we can create more types. So here's an example of another type, which is a complex number. We're not going to go into it, but it's just to show that there are other types that are available apart from the four native data types. Now, we've already printed A and we've printed B, and we just remember that A was hello world, so we got the hello world over here, and that we remember that B was assigned the value of true, which is a Boolean. So when we printed out B, we got true. And then over on our next bit, we want to find out the type of a variable, and what does a type mean. So if we hover over this type keyword, and this is just one of the keywords in Python, one of the many ones. If we do type, we can see that it's the object's type, and when we do that, Python has these native data types. And if we check out the type of variable A, just remembering that A was a string, we get a class of string here when we run our code. So we get a class of string, and we can also put this into, we can also expand and have a look at all of our variables. So we can print, this is the value of C. Again, we're using our print statement, and inside the print statement, we have put in a string for something descriptive for us to read ourselves, and then we can comma separate it and then put whatever we want to see in terms of our values. And in this case, it's the variable C, and the variable C is an integer, so we get this value, the value of C. This is the value of C, and it is 10 because C is the value of 10 assigned on line number 16. And we also do the same for the variable D. And variable D is 10.0, and we notice, we see here that we get this is the value of D, and whereas we got 10 above, we get the 10.0, and so they are different in Python. And we'll show that they're different later, just a little bit later on. And again, we can also just show our complex number, and our complex number was created on line number 23, and this is just for the purpose of display because we're not going to go into complex numbers. But this is a complex number, and it's 5 in the real space and 3 on the imaginary line. That's what this 3J stands for. So that's our complex number here. Our complex number was this variable Z, and this variable Z was set on line number 23. Then we move on and we want to see the type of A. Well, we've already done that one. So because we saw it up here, and we got the class of string when we did print type of A. So we've done it again on line number 32. And straight underneath it, we do the print type of B. And B is, if we scroll up, we can see that it's a Boolean. And we do get a class of Boolean when we run our code down below. And we can do that for all of the types sequentially. So on line number 34, we do this is the type of C. We can do the comma separation, which is quite convenient inside the print statement. And we can put type C. So what happens there is we get this is the type of C, and we can see that we get a class of integer. Why do we get a class of integer? Because C was equal to the value of 10, which is type inferred as an integer. Likewise, when we do the same for the type of D, we get class of float, and again that's because Python has correctly on line number 19 inferred that D is of type float because of the decimal with the 0. And again, we see that the type of D1 is also of class float. So both 10.0 and the 9.99995 or any other floating point number, anything that's got a decimal in there with it will be classified as a float. And in fact, even if we remove this 10 and just left it at 10.0, we would still get a class of float because the decimal is what counts to turn a number from an integer, or to differentiate a number from an integer. Type integer into a type float. And finally, just to prove our point, we've got this is the type of Z, and Z was our complex number, and we see this is the type of Z and it's of class complex. So we've covered our 4 native data types and thrown in an extra one just for the sake of it, and we've also talked about single line comments. We did mention multi-line comments right at the beginning. We'll go into that on another section. So that's our 4 native data types in Python.